All right, welcome back. But first, let's do as review. So if you look at letter A, in order to solve this, you would subtract 9 from both sides. So we have -4 is less than t. Now, I would always write the letter on the left, and that Pac-Man has to still eat the t because it initially was. Because when you go to graph this, it's going to make more sense if your letter's on the left. So -4 has an open circle, and t is greater than, so that's an arrow to the right. And in letter B, something special happens, because when you multiply by a negative, you flip the inequality. So it's really A is less than or equal to -8. And when something is equal to, you fill in the circle. So that's a closed circle at -8, and it's less than, so arrow to the left. Alright, today is the same stuff, except for there's 2 steps now. So we would subtract 7 first. So we have -2t is less than or equal to 14. And then the next step, and if you're losing the negative, make it plus a negative. Now we're going to divide by -2. When you multiply or divide by a negative, you flip the inequality. So at -7, we have a closed circle because of the equal sign below. That right there means we have a closed circle, and it's greater than, so our arrow is to the right. Okay, we're going to, let's distribute the -3 first. So we have -9, and there's more than one right first step, so if you did something else, keep cruising and see if you get the same thing. And 4 squared is 16. So we're going to add 9 to both sides. So 3x is less than 25. And then we're going to divide both sides by 3. So x is less than 6 1/3. Oh, that should be evenly spaced here. Okay, so less than is an open circle and an arrow left. And you might want to actually write 6 1/3 just so you know exactly where it's at. Or you could even go up by 1/3 also. That'd be a fancy thing to do. Okay, in this problem, the first thing I would do is let's just get rid of the denominators. If we make everything a 10, we will have no denominator. To make this denominator of a 5 a 10, you'd multiply by 2. Here you'd multiply by 5, and here you would multiply by 2. So we really have 8x over 10 plus 5 over 10 is greater than 6 over 10. When your denominators are the same, you don't even need to worry about the denominator, because if you multiply this whole thing by 10, it cancels every single denominator. So our problem really looks like 8x plus 5 is greater than 6. Now we're just going to subtract 5 and then divide by 8. And so if you want to count by 1/8, you could go like that. We have an open circle because there's no equal to below, and an arrow right because it's greater than. Alright, letters on the left seem to make it a lot easier to graph. So I'm going to move my letters to the left on a regular basis. So 6 minus 3.5 is 2.5. And since the letters have taken over the left, the numbers are going to move over to the right. So 2.5x is less than or equal to 5. then we would divide by 2.5, getting x is less than or equal to 2. And this doesn't ask to graph. I'm going to assume that you're graphing experts now, so we're just going to solve. And it's always great to check your work, so feel free to plug that in and make sure it works. In the next one, we're going to distribute the 6. And I'm still going to put my numbers to the left. You totally don't have to do this step. So I'm going to subtract 6. 3x and 6 don't go together. So this is just negative 6x is less than positive 3. X minus 6. And then we're going to bring the 3 over through subtraction. So we have a negative 9x is less than negative 6. And when you divide by a negative, you flip that inequality. So x is greater than 6/9, which is 2/3. And another easy way to test is let's plug a number greater than 2/3 in. That's easy to plug in, like 1. If you plug a 1 in here, you get 0 is 0 less than 3, and then that works. So you don't have to plug 2/3 in. Sounds intense. All right, these decimals, let's get them going. So we're going to multiply by 10. So we have a negative 2x plus 9x is greater than or equal to 16x. That looks much nicer. All right, a lot of x's here. So we have 7x is greater than or equal to 16x. We're going to bring our 16x over through subtraction. And that gives us negative 9x is greater than or equal to 0 because there's nothing left on the right. When we divide by negative 9, whenever you multiply or divide by a negative, you need to flip the inequality. 0 over a number is 0. So this is our solution. So anything less than or equal to 0 makes that work. That does have a solution. 0 is on top. If you get 0 next to the x term, that's when it's no solution because you can't divide by 0. The daily info charges a fee of $650 plus $80 a week to run the ad. And the People's Paper, I'll make this daily info. People's Paper charges $145 a week for how many weeks? Oh, $145 a week straight up. So there's no set amount, just $145 a week. I want to know when the daily info will be less expensive than the People's Paper. So I want to know when the daily info, that was $80W plus $650, will be less than the People's Paper. All right. I'm going to go ahead and move all my numbers to the right and move my letters to the left. Well, you know, that's going to make it negative, so let's go ahead and move the 80 to the right. You can totally do what I just said, just switching it up here. Although I don't like this method. Stay with me. We're just not going to have a negative to worry about flipping, so that's the perk of doing it this one time. So instantly, I'm going to rewrite this with my letter on the left. The Pac-Man inequality still eats my letter. And then to isolate the W, you're going to divide by 65. So W is greater than 10. So the solution is, how many weeks will the daily info be less expensive? So more than 10 weeks. So at 10 weeks, they're equal. More than 10 weeks, the daily info is less expensive. Than the People's Paper. And before that, the daily info is more expensive than the People's paper because of that $6.50 fee that you pay. All right, couple special cases. This is what I was just talking about. When you subtract x and get nothing, x cancels, you get 5 is less than or is greater than or equal to 3. 5 is always greater than or equal to 3. So this is all solutions. If this wasn't true, it would be no solution. If it is true, it's all solution. And if you subtract 2x, this time you get 6 is less than 5. This one is no solution because 6 is not less than 5. All right, compound inequalities are and or. And means both things must be true. So if we needed to graph x is greater than 2 and x is less than 6, this is the place right here where it's both of the shadings are occurring. If we want to graph one or the other, we've got everything greater than 2, everything less than 6, and everything that they both cover also. If I look at the first one, I've got greater than 2. This does extend farther up here, and my less than 6 does extend farther back here, but because it says and, I'm not using this extra stuff. And is where both lines lay. So if you look at the orange here, if it says and they go away from each other, it's no solution. This is this. This is an OR graph. The first one is no solution because there's no place that the two orange ones both lay. So an and is an intersection, and an or is called a union. So if you have numbers less than 10, if you think about these numbers, I'm still going to graph it. I think it's easier. So everything less than 10 and everything more than 0. Okay, so let's write some numbers. Okay, numbers that are less than 10 and more than 0 are 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our and decimals, 9.9, 0.1. That's why there's an open circle at the edge. The ones on the outside are going to be things more than 0. This is 10, 11, 12, everything above. Things less than 10 that are also less than 0 is like 0, -1, -2. So our and is right there. Our or would be all solutions because it goes both directions. On the number line, every single number has either the black or the red, now all blue. So every single number is blue. If it says and, the only thing that would be graphed is this part right here in green. So green solution, which is 0 is less than x is less than 10. You can write that as a compound inequality, which we'll get more to tomorrow. Okay, when you have the compound inequality like this, you want to write these as two separate things. So 4 is less than or equal to x plus 2, and then we're also going to write x plus 2 is less than 8. So we just solve each one individually. So if you subtract 2, you get 2 is less than or equal to x, and you know that I'm going to rewrite this so that I don't graph it wrong. At 2, we have a closed circle, and it's greater than, so arrow to the right. When we subtract 2 over here, we get x is less than 6. At 6, we have a open circle with an arrow to the left. You would need to test a number down here to see if these work, because we don't know if it's an and or an or. So if you plug 0 in, that's an easy number to plug in. We would just get 2 in the middle. Is 2 less than or equal to 8? Yes. Is 4 less than or equal to 2? No. So this stuff does not work. So this stops. So our true graph is going to look like that. Typically, when they're written as compound inequalities, they are considered ands. Okay, we're going to break this one up. Negative 5 is less than or equal to 2x plus 3. So I've got this, and then I also have this. 2x plus 3 is less than 9. So let's solve each one. So at 3, I have an open circle with an arrow left. And over here, I'm going to subtract 3. So negative 8 is less than or equal to 2x. I'm going to rewrite that. 2x is greater than or equal to negative 8. When I divide by 2, I get x is greater than or equal to negative 4. So at negative 4, I have a closed circle with an arrow to the right. And again, this is your answer. The external ones don't work. If you want to check, we could check 10. So 2 times 10 is 20, plus 3 is 23. 23 is not less than 9. That's how we know this stuff does not work. Okay, the last slide here, the bell might ring, so see what we can do. We're going to add 5. So A is greater than 6. So I'm going to go up to 6, and I have an open circle with an arrow right. Over here, we're going to add 4. So I have A is less than 1. So open circle with an arrow left. That's a perfect OR graph. So we're done. It's one or the other. In this one, we have x is less than 4. And then it says, or x is greater than 0. So they're going towards each other. Now the blue continues this way. The red continues this way. The word says or. So in this graph, where is one line or the other line or both lines? That's the entire graph. So it's all solutions. No matter which number you plug in, that will work. So that's or. So a quick little recap. If it says and they go towards each other, that's the answer. If it says and they go away from each other, it's no solution. If it says or and they go away from each other, that's the answer. If it says or and they go towards each other, that's all solution because it continues in both directions. Tomorrow we'll talk about if they go the same direction, like this, but don't stress about that just yet. Have a great night, and I'll see you tomorrow.